This video is going to go over adding four vectors together, but unlike my previous video, instead of having the vectors drawn out for us, we're given the magnitude and direction of the vector in words. In this, we're given the angles that the vectors make as a standard position. We're given the angle that the vector makes relative to the positive x-axis. And so the first step in doing a problem like this is to go through and sketch the vectors out. You need to understand what 135 degrees means. 135 degrees counterclockwise from the positive x-axis, or negative 30 degrees, meaning 30 degrees clockwise from the positive x-axis. You should also be able to understand that negative 30 degrees or positive 330 degrees would be the same direction. They'd both be pointing in the fourth quadrant. So let me go through each one of these, drawing the vectors out. So first we have vector A, 5 meters at 75 degrees. So that would look like this. It's 5 meters up 75 degrees above the positive x-axis. And so when I sketch in my components, I have an x component that's pointing to the right and a y component that's pointing up. If I look at vector A, 75 degrees points up to the right. And so that gives me right and up for my two components. For vector B, it's at an angle of 135 degrees. So that's around past the y-axis, which is 90 degrees, over down into the second quadrant. And so 135 degrees means that it's over here. It's 45 degrees from the negative x-axis. And so we have 10 meters at 135 degrees. When I sketch out my components, I have an x component that's pointing to the left and a y component that's pointing up. That's going to be important when I go to calculate those components because I need to include the positive and negative signs for my components. My reference angle, this angle that's inside the right triangle, is 45 degrees. It's 180 minus this 135. Vector C, 20 meters at negative 30 degrees, that points down here in the fourth quadrant. It's 30 degrees below or 30 degrees clockwise from the positive x-axis. And so this vector points down to the right. So it has an x component that's to the right and a y component that's down. This vector, again, could also be described as 330 degrees if I wanted to give the counterclockwise angle. And finally, vector D is negative 160 degrees. So that's past the negative y-axis, which would be negative 90 degrees. And so it's a little bit farther. It's down into this third quadrant. So 160 degrees means that I'm 20 degrees from this negative x-axis. So this vector in the third quadrant is pointing down to the left. So I have an x component to the left and a y component that's down. Now that I have the vectors sketched out, I need to go through and I need to calculate those x and y components. I'm going to use sine and cosine to calculate those components. The sine of an angle is the ratio of the opposite side to the hypotenuse. The cosine of an angle is the ratio of the adjacent side to the hypotenuse. And so we're going to set that up for each of these vectors. Using sine and cosine will give me how big my component is, and then I'll look at my drawing to figure out whether that component should be positive or negative based on whether it's to the left or right for that horizontal component or up or down for the vertical component. So for vector A, the sine of 75 degrees equals AY over 5 meters. The cosine of 75 degrees equals AX over 5 meters. And so I can calculate the size of those components. 5 times the sine of 75 degrees will give me the size of my y component. 5 times the cosine of 75 degrees will give me the size of my x component. And so calculating those values, 5 times the cosine of 75 degrees is 1.294 meters. 5 times the sine of 75 degrees is 4.8296 meters. Both of those components are positive. The x component is to the right, so it's positive. The y component is up, so it's positive. Looking at vector B, the sine of 45 degrees equals the size of the y component, by, over 10 meters. The cosine of 45 degrees gives me the size of bx over 10 meters. So the size of by will be 10 times the sine of 45 degrees. The size of bx will be 10 times the cosine of 45 degrees. And calculating each of those, 10 times the sine or cosine of 45 degrees is 7.071. My x component points to the left, so my x component is negative 7.071 meters. And my y component points up, so it's positive 7.071 meters. Next, for vector c, 20 times the sine of 30 degrees will give me cy. 20 times the cosine of 30 degrees will give me the size of cx. And so I calculate those values. Cx is to the right, so it's positive. Cy is down, so it's negative. So Cx, 20 times the cosine of 30 degrees, is positive 17.321 meters. 20 times the sine of 30 degrees gives me 10. But since Cy is down, my y component is negative 10 meters. And finally, for vector d, 15 times the sine of 20 degrees will give me the size of my y component dy. 15 times the cosine of 20 degrees will give me the size of my x component dx. So I calculate those. Dx is to the left, so it'll be negative. Dy is down, so it's negative. So dx is negative 14.095 meters. Dy is negative 5.13 meters. So now I've calculated the x and y components of all my vectors. My next step is going to be calculating the x and y components of my resultant vector. I refer to those as x total and y total. X total is the total x component, or the x component of my resultant vector. Sometimes I might label it as fx total, if it's the x component of a net force, or I might label it as vx total, if it's the x component of a velocity vector. Here, these are displacements, so I'm just going to label them as x total and y total. So x total is ax plus bx plus cx plus dx. I add all four of my x components together. And the important thing is, if an x component is negative, I include that negative sign. I'm not subtracting something, I'm adding a negative number. So I have positive 1.294 meters plus negative 7.071 meters plus positive 17.321 meters plus negative 14.095 meters. And when I add those together, I get that my x component of my resultant vector, x total, is negative 2.551 meters. I do the same thing with the y components, ay plus by plus cy plus dy. So y total is positive 4.8296 meters plus positive 7.071 meters plus negative 10 meters plus negative 5.13 meters. So when I add all those y components together, I get negative 3.2294 meters. So now these are the x and y components of my resultant vector. But what I want to find is I want to find the magnitude and direction of my resultant vector. So if I have components, the way that I find magnitude and direction is I sketch those components out. My x component is negative, so it's going to point to the left. My y component is negative, so it's going to point down. So when I sketch those components out, I have 2.551 meters to the left and 3.2294 meters down. That means that my resultant vector is this red vector here pointing down into the third quadrant. It's pointing left and downward. To calculate the magnitude of the vector, that's finding this hypotenuse. And so I use the Pythagorean theorem to get the magnitude of that vector. A squared plus b squared equals c squared, or that hypotenuse is the square root of a squared plus b squared, or here is the square root of x total squared plus y total squared. And when I do this, I'm going to just use the size of these components. Squaring a negative makes it positive anyways, but here in this triangle, 2.551 meters to the left means that the size of this side is 2.551. So if I do 2.551 squared plus 3.2294 squared and take the square root, that gives me the magnitude of my vector, which is 4.1154 meters. So vectors have a magnitude and a direction. So I've found the magnitude or the size of that vector. I need to calculate the direction. The direction is an angle. And so I'm going to find this angle theta that's labeled in the picture, this angle below the negative x-axis. So the tangent of that angle theta is the ratio of the opposite side to the adjacent side. So the tangent of theta is 3.2294 over 2.551 meters. And so theta is the inverse tangent of 3.2294 over 2.551. So if I calculate that, to undo that tangent function, I use the inverse tangent function. So the inverse tangent of the tangent of theta was theta. And whatever I do to one side of the equal sign, I do to the other side. So the inverse tangent of 3.2294 over 2.551 is 51.694 degrees. And so that direction is 51.694 degrees below the negative x-axis. And sometimes that's good enough for describing it, but sometimes we're asked to give the standard position of the angle. Sometimes we're asked to give the angle relative to the positive x-axis, with counterclockwise being positive and clockwise being negative. And so that would mean I'm either finding this clockwise angle here or this counterclockwise angle here all the way around. And so calculating those, to find this clockwise angle, I would do 180 minus 56.694. And so doing that, 180 minus 51.694 is 128.306 degrees. But since I was going clockwise, that's negative 128.306 degrees. I also could have done this counterclockwise angle, so it's 180 and then an additional 51.694 degrees. And so that counterclockwise angle would be positive 231.694 degrees. Sometimes you're asked to give angles between negative 180 and positive 180. Sometimes you're just asked to give the clockwise angle or the counterclockwise angle. So you should know how to find either of those. With adding vectors together, the most important thing is to not rush through the problem and not try and do everything all at once on your calculator. Calculate your components. Double check at that step that you have negative signs if the components are negative. Double check that you don't have your x and y components switched. When you go to add your components together, make sure that you don't accidentally switch an x and y component. Sometimes someone will do ax plus bx and then accidentally add cy and then dx. And they have trouble figuring out where they went wrong. And so just be careful with things. Make sure you have everything labeled and that you're using the right values. And then finally, when you're going to find your magnitude and direction, make sure that you sketch it out. Make sure that when you find your hypotenuse, remember that the hypotenuse has to be bigger than either one of the sides. So if you accidentally included a negative sign on your calculator, if you do negative 2.551 squared on your calculator, if you don't put that all in parentheses, it does 2.551 squared and then multiplies by negative 1. And so you might get something that doesn't make sense. Your hypotenuse cannot be smaller than either one of your components. And so sometimes you can catch a mistake that way. Make sure that your hypotenuse is your biggest side. And then when you go to calculate your angle, make sure you know whether you're supposed to be finding an angle and describing that it's 51 degrees below the negative x-axis like I had, or if you're trying to find the standard position of the angle. With some extra practice going through adding vectors together, they might be somewhat tedious problems, but there's nothing really difficult about them.